Okay, Algebra 2, this is lesson 3.1 on absolute value inequalities. So we're going to start with just some review here. This first one here is just a little review of how we solve equations, right? We always do the opposite operations in reverse order of operations order. So for this one, to isolate this 2x, I want to get rid of this positive 1, so I'm going to subtract 1 on both sides. And I'm left with 2x is equal to 8. And then I want to do the opposite of multiplication and divide by 2. And we get x is equal to 4. All right, so now we have an example of an absolute value equation. And if we remember what to do here, we need to remove everything outside of the absolute value bars first, and then set up two equations. So the first thing we're going to do is get rid of this positive 1. So we're going to do so by subtracting 1 on both sides. And I'm left with 2 times the absolute value of x plus 5 is equal to 9 minus 1, which is 8. And then I want to get rid of this 2, which a lot of students will try to subtract, but really there's no symbol in between here, so that means multiplication. So we need to divide by 2, and this would equal 1. So I'm left with the absolute value of x plus 5 is equal to 4. Okay, so now when I'm solving this step here, I need to remember that inside this absolute value, I could either get 4 or negative 4. So what I'm going to do is set up two equations. One, I simply remove the absolute value bars. So I get x plus 5 is equal to 4. And then the second one, I just keep the same thing, but I take the opposite of this number out to the equal sign. So I just put this to negative 4. Okay, and then I solve. And it's going to be solving the same steps. I'm going to be subtracting 5 on both sides. X is equal to 4 minus 5, which is negative 1. And do the same thing over here, subtract 5 on both sides. And I'm left with x is equal to negative 9. All right, so those are my two options for x. All right, so now let's look at another review of solving an inequality here. So again, we're going to solve this the same way we solved an equation. We're going to subtract 1 on both sides and then divide by 2. And I'm left with x is less than or equal to 4. And then pause the video if you need to. I went ahead and put the steps for graphing inequalities here. So pause the video and write those notes in the margin. All right, so what I'm going to do is the first step, circle the number that we're comparing. So that is positive 4. Determine if it's open or closed. And this has the line underneath, so that means we close it. It is including that 4. And now we're going to draw the line. And if the mouth is eating the variable, then we draw the line to the right. If the mouth is eating the number, then draw the line to the left. So the mouth is clearly eating the 4 here. So we are saying that x is smaller than that 4. So that means we're going to shade in to the left. And this is going on that way. Okay? And now we're putting it all together. So now we have an absolute value inequality. So we're going to start the same way. We're going to go ahead and subtract 1 on both sides and then divide by 2. So they're equal to 8. Divide by 2, divide by 2. And I'm left with the absolute value of x plus 5 is less than or equal to 4. There we go. And so what we're going to do here, the first, we're going to set up two different inequalities. The first one, just like before, all we need to do is just remove the absolute value bars. X plus 5 is less than or equal to 4. And the second equation, or sorry, inequality, we need to keep the first part. We need to switch the sign. Okay, so we have a less than or equal to, so we're going to switch that to greater than or equal to, and then we're going to make this answer negative. Okay, and then we can solve from here. So just like before, we're just going to subtract 5, and we're left with x is less than or equal to -1. And we do the same thing over here, and we're left with x is greater than or equal to -9. Okay, and then we just have two inequalities that we need to graph out. Okay, so x is less than or equal to -1. So let's circle -1. That is right. Looks like we're counting by twos here. So here's -1. And let's also do this -9. So -9, that's right here. Now let's determine if they're open or closed. They both have the line underneath. So that means they are both closed circles. And now let's figure out how to graph these. So x is less than -1. So the mouth is eating the number. That means we want to shade this way. And then for this inequality, we have x is greater than -9. So for this inequality, we want to shade this way. Okay, so that just means that um, x can be any value in between these two numbers. Okay? All right. So I've written out the steps for solving inequalities. So go ahead and pause the video, write these three steps down. We've got number 1, set up two inequalities. For the first step, we simply remove the absolute value bars and solve. And for the second one, we're going to flip the sign and make the number that is being compared negative. Okay, so flip the sign and let's flip the sign. Let's make sure we underline that. Flip the sign and make the number that we're comparing negative. Okay. Okay, let's look at a few more examples of these compound inequalities. So hopefully you got these steps written down. So the first thing we want to do when solving these absolute value inequalities is to remove everything outside the absolute value bars. So anytime we have a number in the denominator that we want to get rid of, we can just multiply by that number and it will cancel out. But if you do it to one side, you got to do it to the other side. So now we're left with the absolute value of x minus 3 is less than 8. And now we can set up two inequalities, right? That's step 1. So the first one, we just simply remove the absolute value bars. X minus 3 is less than 8. And then the second one is going to be, x minus 3, switch the sign, and then we make this number that we're comparing negative. Okay, then we just solve. So we're just going to go ahead and add 3 on both sides. So we're left with x is less than 11. And for this one, we add 3. We're left with x is greater than -8 plus 3 is -5. Okay, so now let's go ahead and plot this out on a number line. And so I don't really care how specific you are here. If we want to put maybe a 0 here and show that -5 is here and 11, sorry, not -11, 11 is right there, that's fine. As long as it makes sense, it's not totally ridiculous, that's fine with me. Okay, so let's start with circling the numbers that we're comparing. Well, this is easy because we're making the number line up, so we only have those numbers. Okay, and we're going to keep them open because there are no lines underneath here, so -5 and 11 are not included. And now we can go ahead and share the line. So for this one here, it's the mouth, in quotations, is eating the number, right? So we're going to shade to the left. So we shade this way. And then for this one here, we have x is greater than -5. The mouth is eating the x. So we're going to shade to the right. So if we notice, what's going to happen is these are going to meet in the middle here. So what that means is that x can be any number in between here. So one way I want you guys to think about this is this symbol here is a less than symbol, right? That means less than. But let's think about it as less than, okay? So it's x can be -5 and anything in between -5 and 11, okay? So anytime you have the less than symbol, you're going to have basically the x value is going to be contained inside of those two numbers. We don't know what those numbers are at the beginning, but we will know it'll look something like this, okay? Now let's take a look at this next one here. All right, first thing we want to do is remove the absolute value bar. So I need to first get rid of this +4. We're going to do so by subtracting 4 on both sides. And I'm left with -3 times the absolute value of x plus 1 is less than or equal to -17 minus 21 minus 4 is -21. And now I want to divide by -3, divide by -3. And let's put a little asterisk here. Anytime we divide by a negative, multiply or divide by a negative to solve, we need to flip the sign. Okay, so we're going to be left with the absolute value of x plus 1 is greater than or equal to +7. Okay, so let's make a note of that actually. Go ahead and write this down. Make sure you write this down. Whenever you multiply or divide by a negative to solve, you must switch the signs. Okay, so that's what we did here. We had this less than or equal to sign right here, and we switched it around and made it a greater than or equal to. All right, so now we're going to follow our steps. We're going to set up two different inequalities. One, we simply remove the absolute value bars. So x plus 1 is greater than or equal to 7. And the next one, we're going to flip the sign again, because that's what we're going to do with all of these, and make it the number that we're comparing the opposite. So now we have x plus 1 is greater than or equal to 7, and x plus 1 is less than or equal to -7. Okay, so we're going to solve by just subtracting 1 on both sides, and we're left with x is greater than or equal to 6. And same thing over on this one. We're left with x is less than or equal to -8. Okay, so now we're going to go ahead and plot these out. Put 0 right in the middle, put +6 right here, -8 about right there. And so now we're going to circle the number that we're comparing and determine if they're open or closed. We have the lines underneath, so that means they are closed. These numbers are included. And now we're going to go ahead and draw the line. So for this one here, we have x is greater than or equal to 6, or the mouth is eating the x. That means it is greater than 6. So it's going to be going this way. And for this one over here, we have x is less than or equal to -8. And so the mouth is eating the number. That must mean that x is smaller than. So this one is going this way. Okay, so again, just like I said here with a less than symbol, it's like less than. We're going to say this symbol right here is a, instead of greater than, we're going to say greater than, okay, because it's basically going to say x is either this or that. So anytime you see a greater than symbol, you're going to say that x is going to be either this or that. So the arrows will be going in opposite directions. Okay.